A company in Texas says it will put a woolly mammoth on this planet in about 2 years. It has the money, the laboratory, and some of the best ancient DNA scientists alive. It also has a chief scientist who has already said, in public, that bringing back something identical to an extinct species is not possible. Both of those things are true at the same time, and the space between them is one of the strangest stories in modern biology. Something is going to be born. The only real question is what we are going to call it. This is the animal that might not stay extinct. Picture a woolly mammoth and you probably picture something enormous. A shaggy mountain that makes a modern elephant look small. The measurements say otherwise. A big male woolly mammoth stood around 3 meters at the shoulder, which puts it in the same range as an African elephant walking the savannah today. Some of its cousins were genuinely huge. The woolly mammoth was not the giant of the family. It was an ordinary-sized elephant wearing extraordinary equipment for the cold. The size is the one thing everybody remembers, and it is the one thing everybody gets wrong. The hump on a woolly mammoth's back was not a muscle, and it was not a second skull. It was fat, a reservoir the animal carried with it through the dark half of the year. Fat stores energy, which is the obvious part. Fat also releases water when the body burns it, which matters enormously in a frozen landscape where every drop of liquid is locked up as ice for months at a time. The mammoth was walking around with its own supply line strapped to its spine. That silhouette everyone draws is not decoration, it is a fuel tank. The most revealing thing about a woolly mammoth is something it does not have. An African elephant has vast ears, laced with blood vessels, that work as radiators dumping heat into the air. A woolly mammoth had small ears, and a short tail to match. In the Arctic, every square centimeter of exposed surface is heat, leaving a body that cannot afford to lose it. Evolution did not give this animal a bigger coat and stop there. It went through the whole body, shrinking everything that could bleed warmth away. Under a woolly mammoth skin sat a layer of fat that could reach 8 centimeters thick, and over that, 2 coats of hair. Insulation that heavy creates a problem most animals never face. The extremities go cold, and normal blood struggles to release its oxygen at low temperatures. Mammoth hemoglobin was different. Genetic work on the mammoth genome found changes that let its blood keep delivering oxygen in the cold, so the animal could let its legs and trunk run cool without shutting them down. The coat is what you see. The chemistry is what actually made the Arctic survivable. In 2007, a reindeer herder on the Yamal Peninsula found a baby mammoth lying on a riverbank, so complete that she still had her eyes, her trunk, and her skin. Her name is Lyuba. She was about 1 month old when she died, roughly 42,000 years ago, and the evidence says she suffocated in mud. The cruelty of it is also the reason she exists. The same fine silt that filled her airway sealed her from oxygen and from the bacteria that would have taken her apart. For 400 centuries, the thing that killed her is the thing that kept her. RNA is supposed to be the molecule that does not last. Unlike DNA, it is fragile enough that biologists normally measure its survival in hours or days. In 2025, researchers announced they had recovered and sequenced RNA from a woolly mammoth called Yucca, frozen in Siberian permafrost for about 39,000 years, the oldest RNA ever read. DNA tells you what an animal could do. RNA tells you which genes its cells were actually running. For the first time, we have a readout of what was switched on inside an animal that died before the last ice sheets reached their maximum. Northern Siberia is not a graveyard in the ordinary sense. It is a freezer. Ground that has stayed below zero continuously since the last ice age holds an enormous quantity of Pleistocene tissue. Mammoths, horses, bison, wolves, not fossilized into stone, but preserved as meat, hair, and blood. Nothing else on Earth stores the deep past this way. Bone tells you an animal's shape, frozen tissue tells you its color, its last meal, its parasites, and its genome. Every warm summer, that archive opens a little further, and it does not close again. A mammoth tusk is not a tooth that sits still. It grows in layers, adding new material continuously from the inside for the animal's entire life, so a tusk sliced lengthwise is a timeline running from birth at the tip to death at the base. Every layer locks in the chemistry of the water and plants the animal was taking in that season. Researchers at the University of Alaska Fairbanks realized that meant a tusk was not just a record that an animal existed. It was a diary, written daily, for 28 years. Strontium comes out of bedrock, and different bedrock carries different strontium. It moves into groundwater, into plants, into an animal that eats them, and finally into the tusk that animal is growing. Match the strontium in each layer against a map of Alaska's geology, and the tusk stops being chemistry and becomes a root. In 2021, a team published exactly that, the lifetime movements of a single male woolly mammoth who lived 17,100 years ago above the Arctic Circle. They call him Kik. Across 28 years of life, the mammoth called Kik covered a distance roughly equivalent to going around the Earth nearly twice. Not in a straight line, and not wandering at random, the pattern changed as he grew. As a calf he stayed in a limited area, with what was almost certainly a herd. As an adult male his range widened dramatically, which is what happens to bull elephants today when they leave the female group and start moving alone. An animal nobody ever saw, and we know the shape of his whole life. The last section of Kik's tusk records something different. In his final winter, the nitrogen isotopes climb, until they resemble a carnivore's, and for an animal that ate nothing but plants, that reading has one meaning. A starving body stops living off its food, and starts living off itself, and the chemistry of its own tissue bleeds into everything it builds. Kik died in the late winter or early spring, around 28 years old, north of the Arctic Circle, of hunger. 17,000 years later, we can read the season he ran out. If you want more of the vanished world, subscribe to The Earth Before. The Ice Age Arctic was not the frozen desert people imagine. Across northern Europe, Siberia and into Alaska, stretched a cold, dry grassland, so vast and so productive, that it supported herds on a scale the modern Arctic cannot come close to. Grass, herbs, drainage, dust, a landscape closer to a frigid savanna than to anything alive up there now. Today the same latitudes are wet, mossy tundra that would starve those herds within a season. The Ice Age was not just colder, it was greener. Here is the claim that turns the mammoth from a resident into an engineer. Large grazers do not merely eat a grassland, they maintain one. They crop and trample tree seedlings. Before those become forest, they knock over saplings, they churn moss, and their dung cycles nutrients back into soil fast enough to keep grass out competing everything else. On that reading, the mammoth steppe did not happen to contain mammoths, it existed because of them, and it collapsed into mossy tundra when the big herds went. The animal was not living in the landscape, the animal was holding it open. In the far northeast of Siberia there is a fenced experiment called Pleistocene Park, run by a father and son, Sergei and Nikita Zimov. The idea is to test the engineering claim directly by putting the herds back, bison, horses, musk oxen, reindeer, on ground that has not been grazed this way in something like 10,000 years, and then measuring what the land does. Not a zoo, and not nostalgia, a controlled attempt to find out whether the animals really were the mechanism, using the only method that settles it, run it again and watch. Snow is an insulator. A deep winter snowpack sits over Arctic soil like a blanket and holds the ground warmer than the air above it, which is exactly what frozen ground does not need. Heavy animals moving across that snow break it up and press it down, stripping the insulation away and letting extreme winter cold reach the soil. Measurements inside Pleistocene Park report meaningfully colder ground under grazed snow. It is a real effect at the scale of a fenced park. Whether it can be scaled to a continent is exactly the argument. Every part of that story deserves a warning label. Conservation scientists have pointed out that the evidence for how mammoths actually shaped their environment is thinner in the published literature than the confident version suggests, and that nobody can be certain how an engineered elephant would behave in a warming Arctic that no mammoth ever experienced. The mammoth as climate solution pitch is a hypothesis with a fenced pilot attached, not a demonstrated result. It is a genuinely good idea, it has not been shown to work. Elephant ivory is banned across most of the world. Mammoth ivory is not. The animal has been extinct for millennia, so its tusks fall outside the trade rules, and they can be bought and sold legally. Warming ground is now exposing those tusks across Siberia in quantity, and a single good one can be worth more than a year of local wages. which has produced a genuine tusk hunting economy. The problem is what legal ivory does for illegal ivory. A permitted mammoth trade is a ready-made channel for laundering elephant ivory, and the animal that has been dead for 10,000 years is now implicated in the killing of the one that is still alive. In 2025, the Mammoth project's most concrete result was a mouse. Researchers edited several genes at once and produced mice with thick, curly golden coats, mammoth-style traits, tested in weeks rather than the 22 months an elephant pregnancy would cost. Real achievement, and also a mouse. What is planned next is an Asian elephant embryo, edited for hair and fat and cold tolerance, carried by an elephant mother. What walks out will be an elephant engineered to survive at 40 below. Whether that is a mammoth is not a laboratory question. Extinction may turn out to be reversible in appearance long before it is reversible in fact, and the mammoth, the most famous dead animal on Earth, is where we find out which one we were ever asking for.